So here's a question that reviews several concepts. Using the textbook's thermodynamic data, calculate delta G for this particular reaction. This means we could choose at least two different ways of solving for delta G standard. We could use the thermodynamic data for enthalpy and entropy, and then solve for delta G the first way. Or we could use the standard delta G's of formation and solve for delta G standard for the reaction the second way. We cannot use Hess's law because we don't have a series of reactions that can be summed to get this reaction. So I'm going to use the standard delta G's of formation, and looking them up in your textbook, these are the values that I obtain. Be really careful when you're looking up the standard delta G of formation for water and many other species that do have two different values dependent on the physical state. So H2O liquid is different than H2O gas. I'll then use the equation that allows me to solve for standard delta G for this particular reaction by taking the standard delta G's of formation for the reactants multiplied by their coefficients, and then subtract off the standard delta G's for the, this was for the products, subtract off the standard delta G's for the reactants multiplied by their coefficient. Sum those up, subtract this total value from this summed value. Once I have my standard delta G of formation, part B then asks me to solve for the temperature at which the reaction is spontaneous. Now remember, the process or the reaction only has spontaneity being temperature dependent when the delta H values and the delta S values have the same sign. And we are told here that the delta H value is positive 100 and the delta S value is positive 158 joules per Kelvin. Because they are both positive, then this reaction, the spontaneity of this reaction becomes temperature dependent. If they were both negative, the reaction would become temperature dependent. But if one is positive and one is negative, the reaction is either spontaneous under all conditions, at all temperatures, or it is not spontaneous at all temperatures. You may want to review those concepts. So the best thing to do is solve for temperature when delta G standard is 0. At this temperature, it is at equilibrium, and the reaction is essentially occurring at the same rate in both directions. And then after that, we can decide whether we need to increase the temperature to make delta G negative or decrease the temperature to make delta G negative. And when it becomes negative, then the reaction becomes spontaneous in the direction as written. So I will take this equation, rearrange it, setting delta G standard equal to 0, and solve for T. I get a T value of 633 Kelvin. So is it above this temperature the reaction is spontaneous, or below this temperature that the reaction is spontaneous? Well, because both of these values are positive, in looking at this equation, if delta H is positive and delta S is positive, then the only way in which this could be negative is if this term right here is greater than this term. This term right here multiplied by T having a negative value. So T needs to be greater than 633 to make this expression with the negative sign on it greater than this value right here. So it is above 633 Kelvin that this reaction is spontaneous.